Good morning, everyone. I want to start out talking about the NCCER Soils book or module that we'll be using during week 2. We'll be going through it a little bit, but first let me uh, call your attention to what I have up on the screen. A few notes I took down in that module. You will find some trade terms. These are the ones I consider very important, and not so much as they're going to be on the test, it's just that they're going to be important going forward. Uh, Liquid limit is an Atterbury limit. You'll understand what that means here in a little bit. Uh, it tells you when a liquid is turned into a semi-solid and onto a solid, and then the plastic limit will be the point at which that solid starts turning back into a liquid. Those points or indexes are important in classifying soil. We'll talk about more optimum density, optimum moisture content as I refer to it. Plastic limit, I just described that. Plasticity is the ability to mold the soil like silly putty. Voids, soil is composed of a soil particle, let's say, or a sample of soil is composed of 3 phases. There's liquid or water, and there's air or gas, and there's solid. And the idea of compaction is to get rid of the water and well, you leave some water for lubrication really, but the air, definitely any voids we need to get rid of so that everything's in contact. All the little tiny particles are in contact with each other. Uh, let's see, that's voids, elasticity. Made some notes. Uh, Now this word right here, diatomaceous earth, is powdery stuff that gets rid of fleas and ticks if you spread it in your yard. It's in the module, uh, and you can. It's certainly not on the test, but I thought I'd stick it in there since it is included in the module. And move it on. These, let's go through this. Uh, I wrote these down here because I feel like that they're pretty much on the test. Desirable material for construction projects. It's going to be well graded or gravels or something like that. Types of soil will provide best drainage. The larger particles like coarse grain soils. Also, coarse grains are good for uh, structures, roads, and things like that. And plasticity is a measure in terms of moisture content, the particle size distribution. You can read about that. We will be getting heavily into that as we go into our ebook, Soils and Foundation. Uh, there's a good definition of compaction and its relation to density. There's a sand cone test that we can look at, but we just going to breeze by it. These are things I want you to read because I'm not going to have take up your time all morning to talk about them. Units of measure for soil density is weight per unit volume, like pounds. Really getting good at this. Per cubic foot. That's how it's measured. Ooh, look at that. Pounds per cubic foot. In other words, the more weight that you can get into the same volume means that the more dense your soil is. Uh, Point at which high soil density is attained. Again, that's probably the last page in the module. If we have time, we'll go into that. These are some things I definitely want you to uh, read, and as we go along we'll explain them. I'll run through this module pretty quick here, or at least the first section. That's all we're going to be working on this week. So let me get rid of this fellow and we'll get to, there's the ash toe. We're going to tackle that booger. This a little bit of it. This we'll get into it. I'll start it tonight, but uh, just here is a little bit. Poorly compacted soil naturally settles over time. Several soil classification system. What we're going to be concerned with is this unified soil classification known as and it's done by the American Society of Testing and Materials, testing materials, sorry. Uh, Soil that have poor structural strength with even with compaction can sometimes be improved with additional materials, and that's called soil stabilization. We'll work on it. There's a soil horizon. I want you to look at the different types of soils, and when we say types of soils, there's lots of types of soil, and you think about that. Here's that AASHTO uh, up here. Where's my thing? Let me, oops, this guy right here. That guy is what we're going to really get into, and also the unified soil. This right here, this system, soil classification system. This system classifies soils as coarse grain or fine grain. The next one coming up here is unified soil classification. Uh, and we'll talk about it in just a minute, but there's a lot of things that are the same here. Notice that we have the coarse grains, and we have down here we have the fine grains soils. And notice what determines that. More than 50% of material is larger than the number 200 sieve. Things are going haywire on me. More than 50% of coarse material is larger than the number 4 sieve size. That's gravel. Number 4 is a smaller sieve. And sieves, it's like your flour sifter thing. And then it's broke down into more the well graded, well and poorly graded. And then we talk about the coarse grains being divided into gravels and sands, and more than 50% of the coarse material is smaller than the number 4. But go back up here, and to get into coarse grains in the unified soil, more than 50% of the material is larger than the 200 sieve, and the fine grains are 50% or more material is smaller than the number 200 sieve, and that's where you'll have your silts and clays right here, and the AASHTO will also do that. So I'm not going to spend much time on each of these. I want to get on down and just show you. Be sure and check this out. This information in here. The the soil classification says to find main classes of soils of gravel, sand, silt, and clays. And we just did that, although we did it kind of crudely. But be sure you look through this and get a good feel for that. Have some questions for me. AASHTO is I don't think as complicated as the unified soil system, but sometimes I can do this and I'll walk away and stay away from a week and come back and try to do it, and goodness sakes, I'm lost again. But when you're classifying soils, and I know I'm taking up a little more time than I wanted, but you're going to get a soil sample uh, like so. Whoops. Like so, like so, like so, like so. Where'd it go? right here. This is a soil sample, and we will be dealing with this one, A. So we'll be having, there's our number 10. Remember 68.5. Hope we can read it when we get there. Our number 40 sieve, that's the size of the holes in it, which is like a 10 is large, smaller, kind of back up a little bit. So it's 36.1% passing through that sieve. And the other real important one is the number 200, which is really, really small. And I mean like real small, 2 thousandths of a millimeter small. So we'll be concerned with that. We'll also be concerned with liquid limits, and we'll touch on that, and we'll be concerned with plastic limits, and we'll be using those to get the plasticity index. It's equal to the liquid limit minus the plastic limit, and in this case, as you see, it's 34.1. But those things we will cover. This is just tip of the iceberg stuff that we're dealing with right now, but I want to deal with it. So let's get this guy out of the way. And here you see I've crudely wrote the number 10 sieve 68.5, the 40 sieve 36.1, and the 200 sieve 29.1. Now, to classify soils, and I don't know how far I'll get with this, but we're going to start out with the number 10 sieve, and we're going to see that we have 68.5. So we can't do here. We're going to have to move from here. See, the max for the number 10 sieve is 50. So we got to go over and we got to go down. So that puts us at the number 40 sieve. In this case, 36.71% passed through the number 40 sieve. So we're okay at this point. If I can find my arrow again. There she is. Being my arrow. That was a song. So we can go, the 51 is max. We can go in here, but when we go down, we hit the number 200 sieve, and it has a 25 max, and we have a 29. So we can't go there. We got to move over here to this fellow, and you see it's a 10 max. So we can't stay there. We got to keep moving over, and look here what we found. We found a 35 max particle size for the number 200 sieve. So we have completed. This is no good. We're not here. This is no good. We're not here. And this is no good. Just because we can't make these percent passing percentages line up with what's allowable in here. So what we have, where we finally ended up, is we know we have an A2 soil, because see, we got over into that group. And again, to show you how it's just like the other deal, we have the granular material in here being 35% or less passing, and the silt clay is 35% passing. 35%, really it should be more or more passing. That puts you, I'm sorry, the silt clay material more than 35% passing. So this is little bitty stuff here. These are very, very small particles, and these are all over in this neighborhood over here, like say here. And everything has a subgroup. Like here, we keep going. So we're probably a A26 or A27. And I'll go into that. We're not going to have time because what's going to determine that are these guys. Our liquid limit and our plasticity index. And you see, it's the same thing. There's no liquid limit listed. So we go down to there's no liquid amount listed. But once again, you go over here to this feller right here, and there it is. Liquid limit 34.1, plastic limit 16.5. So if we go back 30.1, 34.1, 16.5, we can go back here 34.1, 16.5. That was cool. The liquid at 34.1. That's a funny one. I gotta work on this. Plastic limit was, I'm not gonna spend, I'm taking up a little too much time. Plasticity, your plasticity index is the, what was that one other one? Just give me 1 second. I'll be, plastic limit was 16.5. So going back here, your plastic limit is, it doesn't have a place for it, does it? PL. Anyway, it's 16.5. So to get your index, it's going to be liquid limit minus your plastic limit, if I can find my say, L minus PL. And in this case, it's 34.1 minus 4.1 minus the one more item, 16.5. I must have my deal at a wrong angle. And that is somewhere around that's 17.6. That equals 7.6. I don't know what I did then. That equals 17 point. I don't know if I'm giving this thing fits here. Six. So once we have that, we would go plasticity index 17.6. Nope, can't go there. Doesn't apply here. 10 max, 10 max, 11 minimum. So here we are, right here. Liquid limit 34.1, 40 max, 40 max. So in a hurry, I have us at, and I think I'm pretty close. A26. Now we'll take that and go further with it. I know it's kind of clumsily put together, but I'm not ashamed of it, and you shouldn't be either. It's ugly, but we'll get there. And if I don't get better soon, I'll quit using it and figure out something else. Uh, Text me some questions if you need to. Go ahead and start Monday uh, on your assignments in the tailgate. There's a video for a tailgate, but I can't. For the life of me, I can't think of what it is right now. It's Goodman, and it's from Auburn University, and it talks about. I think it's about swell, maybe not. Anyway, there's a video on it, and then I want you to comment on what you saw in that video. Then we have a little bit of assignment down there and a quiz. And the assignment has two scenarios where you'll be using the uh, coefficient of permeability chart that I glanced at. I think I showed you. But it's one of those tables. It's a simple things that just tells you the flow of water through a soil sample. And you can tell by the numbers which one would be better for drainage. And that's all I got. I'll see you or hear from you soon. You guys have a good evening. And no, it's evening now. You guys have a good week. How about that?